Okay, we've got another one of these iterations and we're going to do another diagram. And the only difference really is the diagram looks slightly different. It's called a cobweb diagram. Okay, so let's go through this fairly quickly. So x2 equals, well, I know what x1 is, so I'll plug it into the formula. So 2 minus a third of, and then this I take to be my x1, which is 0.5. So I do that on my calculator. So I need to do 2 minus 1/3 times 0.5, and I get 11/6, but of course that has a decimal equivalent of 1.8333, and this is a part of the course where the decimals are relevant. It's numerical methods. We're not going to get exact solutions from this. We're going to get decimal approximations, so I don't particularly want exact answers. I want decimals normally here. Now, to get the other answers, I just need to keep replacing that 0.5 by the previous answer. So if I use my answer button, okay, the next calculation is that x3 equals 2 minus a third times, so I'm substituting into this, but now the x1 becomes my previous answer, 1.833333, okay, but the answer button does that for me. So the next one is 25/18, but that is 1.3888, and then my next one, my x4, and remember, after you've done a couple, they're not really bothered about seeing the working, so 1.537. That's as far as the question asked me to go, but if I keep pressing equals, I can see that eventually it will become decimals, and we can see that the values are getting closer and closer to 1.5, but this time they alternate between being above 1.5 and being slightly below 1.5, but they seem to be honing in on that value. I could check that. Okay, the equation that this iteration will be solving is the equation x equals 2 minus a third of x, and if you rearrange that and solve, you do discover that x is 1.5. Okay, and of course, therefore, on the graph, I'm going to have the graph of y equals x. I'm going to have the graph of y equals 2 minus a third x, and those are indeed the graphs that have been set up for me. I've once again had a starting value of 0.5, so that's my x1. More important to label it x1 than to label it 0.5, but if you put 0.5, put the decimal point in. So what we do is we go vertically to the curve. Well, it isn't a curve this time. By curve, I mean the graph that actually is for the iteration formula. So we go vertically to that graph, and then remember the object is now to go from having a y coordinate of the answer we just obtained. This is the answer we got here. That was the 1.8333. Looks about right. So my first answer for x2 was 1.8333. Okay, but that's a y coordinate here. To make it into an x coordinate, I have to go horizontally to the line. Okay, so now I've got x2 down here. So dot dot dot. That's x2. Okay, to get the next value though, I have to go vertically to the iteration curve. I've already drawn part of that line on. Let's make it solid. Oh, these arrows are nice. Okay, helps to show which direction you're going. I should have done that on the previous example. Go back and put the arrows in on the previous example. Here it was. Okay, this should have had an arrow up here, and an arrow across here, and an arrow up here, like that. Yeah, much better. Right, okay, so if I keep going, I then go horizontally to the line. You can see how this is working out, and maybe you can see why this one is called a cobweb diagram. Okay, so we'll keep going around. This one here is called x3. Okay, fitting x4 on is going to be a bit tough. Okay, x4 is going to be there. So that we can see that we're going alternately above and below 1.5, and as this spirals in along the cobweb, it will reach, well, no, it will never reach 1.5, but it will have that as its limit. It will get closer and closer to it. Okay.